I look blurry.
There we go. You do look a little blurry. Hi, everybody. Welcome to our office hours this week. We've got a lot of great questions, and we're going to jump right into it. So the first one, a student had a question about, sorry about that. A student had a question about how to do the practice hollow box challenge in Java. And their biggest concern was how do they get the box to be different sizes without using the string multiplication operator that we had in Python, right? And basically, if we remember, the string multiplication operator basically repeats whatever string you give it, right? So when you say string A times 5, it'll repeat A 5 times. It creates a new string that repeats A 5 times. And you can print that out. In Java, we don't have that anymore, but we can make something that does with the components of Java. We can make something that emulates that behavior. And repeating, anytime we want to repeat something, that's a loop of some kind, right? So in Python, we did something like repeat 5 stars, and then repeat a bunch of rows, and then repeat 5 stars, and that gave you a box. We want to do the same thing in Java. So Phil, you want to
Sure.
Let's pull up a REPL and we can show you guys some ideas of what's going on here.
All right, let's see. We'll do a screen share. We can share.
Sure, one you want.
Which one is this? This one?
Yeah.
There we go.
Zoom in.
I think I can bigify it.
Bigger.
That help?
Yeah.
Okay. All right, so we can start out really simple here. The actual question is how to print a hollow box of a given size, but we can simplify that for starters and just print a box, make it solid, and then we can figure out how to make it hollow afterwards. The key to this is understanding that we have to do this line by line. It's the only way we can do it because we can only print lines at a time. I can't print part of this line and then the next line and then go back up and print on an above line. So I have to print the lines or the rows that can compose the box first. So we know how many rows we're going to need because we have a size, and that's going to determine how many rows we're going to need. So we can use a loop for this. Whenever we know ahead of time how many times we want a loop to execute, I think a for loop, which is an automatic counter loop, works really well for that. There's a loop that's going to loop through each of the rows. And for now, let's just try a simple print line statement, and we'll just print the word line that many times. This up a little bit. All right, let's see what happens when we try to run this. So we see we've got size set to 5. We got a loop that's going to loop 5 times, and each time it loops, it's going to print the word line, and so it prints the word line 5 times. And this is a good start, right? So we've sort of got the height of our box going here. Of course, we don't want to print the word line 5 times. What we want to do is print 5 stars each time. So we could hard code that. And that works fine as long as our size is 5. But if our size changes to something like 3, Replit doesn't always keep up with your changes.
No, you didn't use. Oh. You didn't use size.
Oh, I didn't use size. I hard coded it here. There we go. So this is correct for the number of rows, but it's incorrect for the number of stars in that row. So what we need to do is, instead of printing a fixed number of stars, we need to print a variable number of stars. So we can use another loop for this. And we can print 1 star each time. We'll try this. Let's see what happens. Oh, that is not what I wanted. I think it printed out the appropriate number of stars, 3 and 3 and 3, but it printed every star on a different line. And that's because I'm using the print line when I should be using print. Let's see what happens when I try this. Okay, now they're all on one line. I need these first 3 to be on one line, the next 3 to be in a separate line. So after it prints that column, I need it to print a line by this. That's better. Let's see if it works for 5. 5 high and 5 wide. Let's see if it works for 10. Pretty good. So here we have a solid box. We're able to print a solid box of a given size. So now we can work our way towards printing a hollow box. So in this case, the top and the bottom are going to be composed of size stars each. But each of these lines that's not the top or the bottom is going to be a star followed by a number of spaces followed by a star. So there's going to be 2 stars here and then size minus 2 spaces. So there's going to be a star followed by size minus 2 spaces followed by a star. So instead of printing a star all the way through, I need to print star start with, and I need to print star to end with. And I need to print a number of spaces that is size minus 2. Let's try that for size 5. All right, but I'm doing that for every single one. So I've lost my top of my box and my bottom of my box. So what I need to do is for the top of the box, I need to print size stars. And for the bottom of the box, I need to print size stars. So the top of the box is going to be so helpful. 5 stars, or size stars to be more technically correct. So I can say and I need to print that number of stars. That will be the top of the box. And once I've printed the top of the box, I can move on to the next line. I'm going to need to do the same thing for the bottom of the box. And for the middle of the box, I'm going to need to do size minus 2 rows. So if size is 5, I just need these 3 rows. And each of those rows starts with a star, and then size minus 2 spaces, and then ends with a star. So let's try this. Oh, that's not good. Sizer.
And count isn't defined.
There are my variables.
Incisor. You copied incisor.
That's why you don't copy and paste. If you copy and paste, you're probably copying and pasting errors. Ooh, that's looking pretty good. Let's see what happens if I make size 7. It's looking pretty good.
Cool.
So it's a matter of breaking down the functionality and building up the pieces you need. If I want to be able to print a line of stars of a certain size, I can write a loop to do that. If I want to be able to print a number of rows that are composed of a particular structure, a star followed by a number of spaces followed by a star, I can do that. And of course, I can leverage functions or methods in Java, and I can put this functionality in a method so that I'm not repeating myself down here. And I could just have a method called, print stars, and you can pass it an integer to tell it how many. I could make another one that prints a side of the box, which is a star with a number of spaces and another star, and I could pass it a size, and then I could build this out of those. Lots of options here. So hopefully this helps give you some idea on how we might tackle a problem like this. Obviously, it's different in Java than it would be in Python, and that's going to be true for all programming languages. All programming languages have their advantages and disadvantages, their strengths and weaknesses.
Yeah, awesome. Great. So our next set of questions comes from Bill in the discussion forums, and he has a bunch of great ones. So the first one he asked is, are there programs that can translate code from one language to another? And there absolutely are. The problem is they're often not the smartest programs. So if there is a particular sort of structure that is not present in one language or another, for example, we were just looking at the string multiplication operator in Python. If a program exists to translate between those things, it would have to be smart enough to recognize that situation and spin up a loop with its own variable names and stuff like that to make that happen, right? For that reason, a lot of times these code translation languages are not very commonly used because they end up having a lot of weird little. The translation is not very good, is what it ends up being. So often when we want to port from a program from one language to another, we might use one of those language translation tools to do a first pass, and then you have to go through and clean it up or fix any places that the program got confused and stuff like that. But they're not super commonly used in my experience.
Right. No, there are some places where they are used. Again, not super common, but they are used, and the technical term for that kind of a program is transpiler.
Transpiler.
And some common examples would be there's a transpiler for the language CoffeeScript, and it transpiles CoffeeScript into JavaScript. And there's another one for Microsoft's TypeScript, which transpiles into JavaScript. So JavaScript runs on all browsers. But if you've ever programmed in JavaScript, it's a very challenging language to program well in. It's an easy language to program in. It's a very challenging language to program well in. And the languages like CoffeeScript and TypeScript are an attempt to make languages that are easier to program well in, and yet they'll still run on the browser, which only runs JavaScript. So the transpiler transpiles from the TypeScript or the CoffeeScript code into JavaScript. And of course, those two languages, CoffeeScript and TypeScript, the languages themselves are designed to be compatible with JavaScript. So the transpiler already has an advantage. But if you're trying to take a program written in a language like Python and translate that into an equivalent program in Java, that's a huge challenge.
Yeah.
And the programs that do that, a lot of them are very finicky.
Yeah.
To say the least.
Totally. So they exist, but they can be a help, but they're by no means because they're designed to be general purpose. They're by no means the end all be all, and you always need some human intervention to usually make the programs work in different languages. The next one was asking if we could talk about the languages associated with a bunch of different disciplines and careers and technologies. And Bill listed a whole bunch of them here. The ones that I'm most familiar with are things like data science, data engineering, embedded systems, image recognition, and machine learning, and a little bit of virtual reality stuff. In data science, data engineering, machine learning, and even image recognition, those are high data intensive algorithm type environments where you're processing a lot of data. Time is critical. You're doing a lot of math. You need to do it very efficiently, and a lot of times those algorithms are written in a low-level language like C or C++. And sometimes more commonly, they're starting to be written in Python with some libraries that are written in C or C++ to back them up. So it's a really weird balance of performance and ease of building an architecture, because you've got a lot of big moving parts, and those individual parts have to be very fast at what they do, but you've got a lot of them talking to each other. So Python is used to make them talk to each other, and then the Python actually calls out to C and C++ programs that do the efficient data processing and then hand the data back to Python to be passed around to different pieces. So you get a little bit of both worlds of ease of building and prototyping structures in Python and the speed of C++. But you have to write all those low-level, high-performance applications in C and C++ first.
This one, websites and mobile app development. So websites, there's generally two sides to a website. There's the part that runs in your browser, and that's almost always some version of JavaScript or something that transpiles to JavaScript. And on the back end, the servers that your web browser is talking to, a lot of times that code is written in a combination of Python and Perl and Java and C#. They're running heavy-duty servers back there, so they can build what they want with whatever languages they want. For mobile app development, to some degree, there's a platform dependence here. If you are an Android person, a lot of that is done in Java. Almost all of the Android stuff is done in Java. If you're an iOS person, a lot of that's either done in Objective-C or increasingly now a programming language that Apple's created called Swift, which a lot of people are big fans of. And it's supposed to be a much more productive language than Objective-C. There's also a question about database management here. There are a lot of different kinds of databases out there. The kind of the granddaddy of all database types out there is relational database systems, which is still a very popular, very useful type of database to use. And the language associated with that is called SQL or SQL, Structured Query Language. It's actually a fascinating programming language. It's what's called a declarative language. The languages that we're learning in this class are called imperative languages because we're telling the computer what to do step by step. In a declarative language, we tell the computer what we want done, but not how to do it.
Yeah.
So, which is interesting, right?
Yeah.
So, let's see, what else is in here?
So user interfaces, so UX, GUIs and stuff like that. Most languages have a user interface sort of library. So this is an interesting question because there are languages that each of these industries that Bill mentioned use typically, but more often it's a set of libraries that are very specific to that application. For example, image recognition, it can be done in Java, and it can be done in Python, it can be done in C and C++, and it can be done even in JavaScript. But the library that most commonly is used is called OpenCV, and it's built and ported across all of these different languages. So the structure and how that library works, it's open computer vision, how that library works is common across all these platforms. So if you learn the library and you learn a little bit of each of these languages, you can build it on a whole bunch of different platforms and work around it there. So specific libraries like Qt are multi-platform libraries for user interface design. In Windows itself has its own built-in library for the typical activities that you would do for building a Windows application that has a GUI for making the window panes and buttons and text input and all kinds of stuff like that. So it's really that one is very specific to the platform, the language you're going to use, and the language you're going to use. There's going to be a different library for user interfaces for each combination of those things.
This one also is interesting. Ethical hacking was one of the categories here. I like the fact that you put ethical on the front of that. There's a lot of languages that you can use for that, but I think the two primaries are going to be one very low-level language, which is C, which will allow you the most access to the machine at the machine level. And then Python is very popular for a high-level approach to that when you're trying to get a lot done in a short amount of time.
Yeah.
So, but we live in a world today in which these application domains are not really limited by particular programming language. There are probably programming languages that are more dominant or less dominant in those domains, but it's not exclusive as it kind of was maybe 20, 30 years ago.
Yeah, and there's even some specialty programming languages for much more niche applications, like the data science and data engineering ones. You might see a lot of programs written in the R language, which is based on being able to do lots of statistics very efficiently from a programming standpoint. So you can build up an architecture of data processing very quickly using the R programming language. And it has roots in a combination of C and Python and all kinds of weird stuff. So its syntax is a little odd, but it's got a lot of stuff built into the language to support statistical processes.
All right, here's a question. What are your experiences with meetups, hackathons, and other social programming events? Several years back, one of the meetups or things that I used to go to is the Desert Code Camps, but I haven't heard from them in a while. I think they stopped doing that, but there's a lot of things available. I'm a big fan of these kinds of things. Those of us that are drawn to these kind of technical fields do tend to be a bit introverted and maybe under-socialized. So it's a good opportunity to get out there and meet people that have some of the same interests as you and expand your interface with these people, and you'll learn all kinds of new things and meet new people and get connected to new ideas and new projects. So definitely a fan of it. I'm not exclusive in any way. And in my opinion, if you find something and it sounds the slightest bit interesting, you should go and check it out. Here at ASU, we have a number of clubs associated with computer science and software engineering and hacking and these kinds of things. And I encourage all my students to go at least once or twice to any club that they're interested in and give it a try, talk to the officers, see what events are going on. And if they like it, then become a regular member.
Mm-hmm. Totally. This is a great one.
That's
okay.
a good one.
So this question is, how does a computer compress information for zip files? The specifics of the zip compression algorithm is a mystery to me, but it's based in some simpler basic kind of compression algorithms. And basically the idea is that in any kind of compression algorithm, what the computer is doing is it's going through a sequence of information and it's looking for patterns, right? So instead of storing, say you've got a file and it's got 3 zeros in a row, then it's got 3 ones in a row, then it's got 3 zeros in a row, so on and so forth. And it just does that for 1,000 sequences, right? There's really only 2 patterns in that file. It's the 3 zeros, and then the 3 ones, right? So what the compression system does is it says, I found one pattern, which is this pattern of 3 zeros. I'm going to store that away and say, this is pattern number 1, right? Then it looks at the pattern of 3 ones and it says, this is pattern number 2. And what it does when it compresses the file is it builds this table very first off, which is the translation table. And it says, pattern, if you see a 1 in the file from here out, it's 3 zeros. If you see a 2, it's 3 ones. And that's what goes into the new compressed file. Then it just does whatever the pattern numbers are. So it says 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And it's saved 2/3 of the size of the program by doing that. Because instead of 3 symbols, you have 1 symbol and a little bit of the translation table at the beginning. The zip algorithm is way more complicated than that, but all compression algorithms that are what we call lossless do something to that effect. They try to look for patterns and represent those patterns as a shortened representation rather than a big full-on representation. And then the decompression program on the other end just goes and does that same replacement and says, when I see a 1, I'm going to replace it with 3 zeros. When I see a 2, I'm going to replace it with 3 ones, and you get the original file back out the other end. So that's kind of how it works.
Yeah, no, that's the gist of it. In the details, there's a lot of devil. There's a lot of specialized ways to do that. One of the earliest compression techniques that they used with bitmapped images long ago was what was called run length encoding.
Mm-hmm. Yeah.
So if you look at, especially bitmapped images from years ago when we had maybe, 16 or 8 colors that we could work with. So you've got a whole screen and there's only 8 or 16 colors on that screen. So big chunks of that screen are just the same color. And so what they would do is they would just start looking at the pixels and say, well, this one's green, and this one's green, and this one's green, and this one's green, and this one's green. Well, how many of them are that are green in a row here? There's 130 green ones in a row here.
Yeah.
So it would replace those 130 green ones with just a simplified version that says green 130 times.
Yeah.
Followed by the next color this many times.
Yeah.
So there's a lot of different ways that you can do this. It's definitely worth looking into. And it's still an active area of research.
Yeah,
so
absolutely. Yeah,
cool.
Especially with things like video coding, video encoding, and stuff like that. The new codecs that are coming out, I think there's a consortium that's developing the AV1 codec for video encoding. It's what YouTube is planning on re-implementing. Right now we have H.264, which the idea is, how do I take the image that you're seeing that's being recorded from our computer, compress it down into a short version, a smaller version that can be transmitted live without using a lot of bandwidth, and then reconstructed at high fidelity on your end. And how do I do that efficiently and so that there's not many hiccups between when we're broadcasting and when you're receiving and stuff like that. That's really challenging, and a lot of new development is happening for that all the time.
All right, this next one I think is more up your alley. Information on learning assembly.
Yes. I promised to do this and I totally forgot about it. So I will come back to this one because Bill asked this before, and we said that I said that I would go and see if I could find something for him, and I totally forgot about it. So I will make myself a note, and I will come back to you on that one, Bill. I'll answer you in the discussion forums in this discussion and give you some resources on how to learn assembly a little bit more.
Okay, this next one is sophisticated, and it's probably outside of both of our areas of expertise, but the question is regarding patent laws for software. How can we learn about them? How much of another program can you borrow when you're developing your own software? Do people patent functions and algorithms and variable names? Are the patents more about the application or the user experience? What little I know about this, historically, yes, algorithms are absolutely patentable. A function is an algorithm, so some functions are patentable. Variable names in and of themselves are not going to be patentable.
No.
But there have been cases where when you write what's called a software library, you expose the functionality of that library through named entities, usually the names of functions. And that collection of names is patentable.
Right. Yes. Which is very odd. And the reason, so patent law as it applies to software is kind of a weird world, because it's we know of software, and you're experiencing software as a document that you write, and a lot of the original intellectual property protections were based on that. So rather than patenting a program that you wrote, you would copyright it, just like you would copyright a book or you would copyright something like that. And that was your protection for that program. Still can and do, companies still can and do copyright programs all the time. The challenge becomes if you invest time and resources in developing a new algorithm that solves a problem in a unique way, just like you might use time and resources to develop a new chemical processing process, right? It's a process, and you're not patenting the plant that does the steel refinement or something like that. You're patenting the specific process so that somebody can't come along and use your process and compete with your particular plant. So you patent the process, you patent the algorithm rather than the specific instance, and that's having both copyright and patents on what could be the same thing is a contentious area for patents and software patents overall. And there's a huge debate about whether or not we should allow software patents and all kinds of stuff like that. So it's very complicated. We have whole classes on the university campus, whole sections, multiple classes of information on specifics of how software patents and copyright and how all that stuff works. I've got a patent. When I was working for Boeing, I got a patent on a piece of software that I wrote for them, and the patent looked nothing like the code that I wrote because the lawyers looked at it, and like, well, we're not patenting the code, we're patenting the overall process and how that works. And they turned it into the patent language, and I couldn't even read it because I didn't understand what the patent language meant. So it's very complicated, and to get a software patent requires a lot of resources from a legal entity, very, very much so.
I think it's worth talking a little bit more about this part of the question here about how much of another program's code can you borrow when you're developing your own software. So this is more to do with copyright than patent here. So in general, if you are copying code or including code from another author into your code, that's a risky endeavor. Very often there should be copyright notice embedded in the code that you find. And if that copyright notice isn't there, you should assume that it's fully copyrighted and not fair to use.
Yes.
You can be sued. If there is a copyright notice in there, then you can look at the specific notice and see under what rights you can use it. So different copyright notices will provide different explicit valid uses for it, and sometimes it's full use as long as you attribute. And in that case, you're welcome to go ahead and copy that code and even often modify that code as long as you maintain the original copyright notice that this code originally came from this person who owns the intellectual property.
Yeah, and often you'll see specific licenses. Mm-hmm. So there's the Creative Commons licenses. Those are usually for types of media and things like that, but sometimes you'll see them in code. The most common ones that you'll see where it's like in the open source types projects where you can explicitly use the code as long as it's attributed is the GPL license, the new public license, is it the general public license?
I think it's general public.
Yes, the general public license. So you'll see the GPL in there, and you always have to include the GPL. If you make changes to the code, you have to, again, release it open to the public. So you can't take ownership of a public resource like that. There's also the MIT and Berkeley licenses. Those are open source licenses. And they've all got their own specifics and use cases and stuff like that. But generally, if you find a piece of code, you should avoid using it in your own programs unless they give you explicit permission. And if they do, you should always attribute it to them. You never want to take, especially in a corporate environment, you never want to take credit for something that you did not develop yourself.
All right, our next question is, when you decide to learn a new language, how do you do it? Do you take a class? Do you buy a book? Do you talk to your coding buddies? Answering yes to all three of those is totally valid.
Yeah.
I think a lot of it depends on your current level of experience. So if you've never learned a programming language before, I think taking a class like this one is a really great way to start, because someone or someones have put together a curriculum, a set of goals for you to meet and activities for you to engage in to meet those goals. And it's a good way to kind of sort through all of the things that you're not really familiar with. Once you've taken a class like this and you've got a pretty good handle on one programming language, or in this class, you're going to have, somewhat of a handle on Python and somewhat of a handle on Java, I think you're in a pretty good position to go and start looking at books in a bookstore or online that are tutorial style for a particular programming language and following those on your own. At the same time, it's really cool to be associated with someone or some people who share your interest and are either learning the same thing at the same time or have learned it ahead of you, and you can talk to them and say, here's what I'm learning right now, and can you help me understand these concepts? So all of the above is my answer.
Yeah, absolutely. For example, Phil and I started learning JavaScript, and that kind of fell by the wayside since we got busy. But we sort of set out to learn it on our own. So we went from a bunch of online resources and worked some tutorials. And we had for a while, we had a meeting every 2 weeks where we'd show each other what we were working on and see how to do it. And usually when I set out to learn a new language, I've learned, I learned C and C++, and I learned Python are my big languages. I've written the most code in those languages. And once I got those nailed down, it's easier for me now to pick up a new language. So usually I'll set out to do a thing with that language. I set some sort of functionality goal, some sort of development goal. I want to make a thing that does this. And then I work towards that in the language that I want to learn. So I have a place where I want to go, and I get the skills that I need in that language as I work towards that specific goal most of the time. Because I'm usually like, I want to build something, I want to make something that does this. And that's how I go about learning the language itself.
It depends on what your personal goals are, but amongst many of the professional programmers that I know, so the people that spend most of their day designing and writing code, very common recommendation is you should be learning one new programming language a year.
Yeah.
So and it's not necessarily the case that, and this is going to be the programming language that I use from now on. But once you start to kind of learn a second and a third and a fourth language, you start seeing that these different languages allow you to think in ways that you couldn't clearly think in the languages that you knew prior. And now that you can think in these ways, you can solve problems in the languages that you're more fluent in ways that you couldn't before.
Yeah.
So this learning new programming languages is a very valuable thing for programmers, even if they have no intention of using that specific language. So seeking out interesting, different, even unique languages and learning those for fun also has a very productive side to it.
Yeah, totally.
Let's see here. Are there personality stereotypes amongst coders? Like, are Python coders known to be hippies, or full stack developers jacks of all trades and masters of none? Do coder stereotypes come to mind? They do, of course they come to mind. Yeah, I mean, if you ask most people that you encounter, tell me about coders and programmers, everybody's got some stereotype in mind. We see movies and stuff where you have your hackers who can apparently do anything with the keyboard lightning quick.
Right.
Yeah. There's always some magic keyboard combination for whatever it is that you want to do.
Yeah.
I think that a lot of the stereotypes that we have, that society has about coders and programmers, are becoming much less useful these days, because I think they're very limited in the picture they draw and don't accurately reflect the diversity of the community of software developers and programmers. Typically, and even I come from an older age, but even if you ask me to think about coders and programmers, I tend to think of a younger guy, not particularly extroverted, probably spends a lot of time in a semi-dark room drinking caffeinated beverages and coding in front of multiple monitors.
Yeah.
That's pretty unusual these days, I think.
Yeah.
When I actually go and hang out with some of my good friends who are professional software developers, they work in well-lit offices, they keep regular hours, they have wives and husbands and families, and
they do outside
hobbies.
They do outside things, they play sports, they're sports fans, they're doing all kinds of stuff. So the thing is, I don't think a specific language or even a specific industry attracts a certain kind of person to it. And the stereotypes that we're used to are artifacts of history, and the sort of they came in before a time that computing was so ubiquitous, right? It used to be there was only a few computers in the world, and the few people that got to work on them were the nerdiest possible people, right? Now computers are everywhere, everybody can learn to program, and because of that, everybody does program. Much different kinds of people are programming. So I don't really see these stereotypes holding up very long anymore at all. I hope, actually, the more different perspectives we get, the more interesting programs we'll see, and more cool stuff will happen.
Totally agree. All right.
So this next question is from a student that had a question about how to do the Algebra Tutor program, and they're struggling a little bit. And they're looking for some specifics. And we want, part of the point of this class is to make sure that you are that you're learning and challenged by these programs. And we don't want to give you the solution. We want you to build your problem solving skills in how that works, right? So what we're going to do here is not give a solution, but think through some of the little bits and kind of do our own design review idea here, and try to make sure that you're started on the right foot and have a place to go, right?
So I'll do a screen share again here.
Awesome. Yeah.
Bigger. Okay, so this is the instructions for the Algebra Tutor assignment. And you've all probably read through this. And absolutely, this is a meaty project. There's a lot going on here.
Yeah.
From the perspective of this project, most of the projects that we've asked you to do prior to this are relatively simple. Maybe 1 or 2 layers deep. This is probably at least 3, and in some cases maybe 4 layers deep. The key skill of computer problem solving is breaking a large problem down into smaller pieces, and then repeating that process until you have pieces that are small enough that you can solve that by writing a little bit of code.
Mm-hmm.
And with the tools that we've learned up to this point, the key element of abstraction for us is going to be a function. So for each thing that the program needs to do, we want to write a function to do that one simple thing. So after you read through the instructions of an assignment like this, you want to start looking at it in terms of, well, what are the things that this program needs to do? And so when you get to a line like this, the user will be presented with a menu of options to study in one of 3 modes or quit the program. Well, the user will be presented with a menu of options. So we could write a function to do this. And the only thing this function would do is print a menu of options for the user. And so that's just going to, in Python, be a series of print statements, or in Java, be a series of system.out.println statements. in which we could make a little menu, 1, solve for Y, 2, solve for M, 3, solve for B, and 4, quit the program. Something like this. And that's the kind of thing that it's going to happen somewhere in this program. We can carve that little chunk out, and we can write a simple function to do that. And so as we look through this set of instructions, we'll find more things like this. Here it says that in each mode, all of the given values should be randomly generated integers between -100 and +100, which means we're going to need to be able to generate randomly integers between -100 and +100. So this is something the program is going to need to be able to do. We can write a simple function that does this. And then, as soon as I write this first function that's going to present the menu, I'm going to write a little bit of code that actually calls that function just to prove that it works. And then once that's working, I'm going to, maybe I tackle next this function that just generates and returns a random integer between -100 and +100, and write a little bit of code to call that and to make sure that it works. And then here it says once the student selects a mode, so the student's going to have to select a mode, or in other words, the student's going to have to select an item from the menu. So we're going to need to be able to make the program able to do this. We can write a function that gets the user's menu choice, and it's probably just going to prompt the user to input an integer, 1, 2, 3, or 4, and can return that to us. And so what we're doing is breaking off little pieces of this program and solving those little sub-problems. And this is going to make solving the bigger problems much easier because we've already solved the small problems. We're already going to have a method that we might call it display menu. So anytime we want to display the menu, we just say display menu. And we might have a method called, get random integer. And anytime we want that random integer, we just now say get random integer. And anytime we need to get the user's menu choice, maybe that's the name of our method, get user menu choice. And so we can compose the more complex aspects of the solution out of these more simply composed pieces.
Cool.
What do you think? Do we want to say anything more about it, or is that a good start?
I think that's a good start. The student actually commented in the chat that he was able to figure it out up until a specific place, and then I gave him a quick little hint. He was struggling with keeping track of how many, figuring out how to keep track of whether or not they got 3 in a row. And I gave him a little hint outline on how to make that work. Bill has another question from the chat on which types of coding could lead to a coding job in the shortest amount of time. There are 2 or 3 months code camps that exist for website development. Do you know of types of code jobs that you could land quickly? That is really hard.
That's a tough question.
Yeah.
And those 2 or 3 month code camps that are preparing you for a particular job, they're usually very focused on a very specific job. They actually usually have companies that are lined up to receive their graduates.
Yeah.
And those 2 to 3 months are usually, 9 to 12 hours a day, 6 to 7 days a week. It's super intensive.
Yes.
I don't think it's an ideal way to learn things because a lot of the stuff that you're learning when you're learning to program, it takes time to really absorb those concepts and learn to apply those concepts. Not that that some of these coding camps aren't good paths to a starter job as a career in programming.
Yeah. One of the guys that did one of our industry moment videos, David, he works for Allstate, and he got his start in coding through Galvanize, I think, which is a 40-day code camp. And he said it was insane. It was intense. He was working like 100 hours a week on this thing. And when he got out, he got his first job right out of the box working for Allstate in their software development group. And he doesn't regret it at all. He loved it. He thought it was fantastic. But what he did miss was the fundamentals, which is like that we're trying to teach you in this class, and the fundamentals of computer science, which is like doing algorithms and data structures and stuff like that. They taught him a lot of languages. They taught him a lot of tools but they didn't. There's not enough time to integrate sort of the body of knowledge that you get there. So there are fast paths into a software development career, but you're always going to be missing if you do a quick path. You're going to be missing some set of skills or have weaker sets of skills, and you'll develop those over the time with practice. You know, it's entirely. I would suggest following what you're interested in more than what is sort of employable in the short amount of time. I think that'll serve you better overall.
Right. And I would also recommend this. I mean, if you're definitely serious and interested about getting a job as a programmer or software developer, I would start applying for jobs as soon as possible. Just be willing to be rejected, which is totally okay. It's a really great way to figure out what companies are looking for, especially the companies that you might be interested in. So you might apply and maybe you don't hear anything back. You might reach out to their HR department and try to find out, you know, I applied, I didn't hear back. Is there a particular reason? And they might say, oh yeah, we did. We reviewed your resume and you were missing these pieces. And so now you've got some idea of what you might want to target in your own development. So I need to beef these pieces up, and then I'll submit my resume again. And if you get the opportunity to interview, that is a great opportunity. Even if they say, thanks for interviewing, but I don't think you're a good candidate for us, it's an opportunity for you to ask and say, okay, well, what am I missing? What if I had these skills or this knowledge or this experience, what would have caused you to consider hiring me? And that's a great way to identify the pieces that you want to develop in order to get the specific job at the specific companies that you're interested in.
Yeah, great. So I think that's all we got time for today. So thanks everybody. Keep your heads up as we slog through. This is the hardest part of the course. These 2 weeks between the midterm, the end of Python, and the start of Java, these are by far the hardest parts of the course. If you make it past this, you will I won't say you will. You're guaranteed to survive.
The pressure drops.
The pressure drops significantly. And we'll continue learning together. Keep sticking in the discussion forums and keep posting there. And we'll see you guys in a couple of weeks.